All right, now what we're going to do is we're going to do this without straightening out the system. All right, we're going to do it, you could call it the legitimate way, because some people struggle a little bit with the idea of bending space, right? We're just going to straighten out the system, but it's not straight. I just, to see it done in what's a more legitimate way can sort of help verify it and make you more comfortable about using that other way of solving the problem, the straightened out system way. All right, in this situation, now we have to consider two different objects, right? We're not going to call it a system. We're going to consider two different objects and a tension that acts on each of them upward, but in opposite directions, okay? Well, it's upward, but their accelerations are opposite. You'll see what I mean. We have Robin Hood, who must be green, of course, and acting on Robin Hood, we have tension acting upward, and we have Robin Hood's mg acting downward, okay? Over on the right-hand side, we have a chandelier. Chandeliers have fire, so here's T. Now, what do we know about the weight of the chandelier? It's greater than T, isn't it? All right, so I'm going to draw that a little bit longer. Big mg. I didn't do a very good job again over here of showing that this was out of balance, but you can sort of tell. All right, so now let's solve on the green side. Net force equals ma. All right, that's Robin Hood's mass. Net force is equal to T minus mg. Well, now, if we're solving for tension, what are we going to end up with? We already know this. Elevator equation, right? T is equal to m times the quantity g plus a. Okay? Now, actually, we don't want to do it that way. We want to, because we're going to have to mg plus ma. We're going to solve for a later, so instead of having to separate it again later, let's not gather it. Let's not factor out the m. So now, this is for an acceleration that is in this direction, and we're calling that upward. Okay? Over on this side, still calling upward positive. All right? Upward is positive, but the acceleration is downward. Okay? And here, we're going to have the elevator equation again. All right? So net force is equal to big M times A. Net force is equal to tension minus big mg. All right? And now, we're going to get, in fact, over here I'm going to say A for R, for Robin Hood. Okay? The acceleration of Robin Hood. All right, so over here, we're going to get the elevator equation again. We're going to get T is equal to big mg plus big ma, and A of the chandelier. Now, what do we know about the acceleration of the chandelier and the acceleration of Robin Hood? They're the same magnitude, but they are opposite in direction, okay? So what we can say is right here is that AC is equal to negative AR. Got that? Okay. So we can rewrite this red one as T, come on, T is equal to mg minus big M AR. All right? So now we have two expressions for T, and we'll set those equal to each other. All right? We've got the green expression, mg plus MAR is equal to big MG minus big MAR. All right? This is easy right here. Now what we're going to do is just gather our A terms and our G terms, right? So what do we have to add to each side? I'm going to go blue here because red plus green always makes blue. All right, so we're going to gather the R terms. Okay, so we're going to add this to each side. So we're going to get big M plus little m times AR. Got that? MAR plus big MAR, added this to each side, and then I factored out the AR, the acceleration of Robin Hood. So now what am I going to do to this? Right here. I'm going to subtract that from each side, so I'm going to get M minus m times g. Got that? So now what happens? I divide through by big M plus little m. I get the acceleration of Robin Hood is equal to big M minus little m over big M plus little m times g, which you'll see is exactly the same as we got before if you go back and check that other one. Okay? And that's taking upward to be positive and Robin Hood's to be positive. If we did the same thing but solved for over here, we solve for this thing calling downward acceleration, we would get a negative of AR. Okay? So, not that one example proves a procedure, but hopefully you're more comfortable with the demonstration that you get the same answer.